second, please. Can you hear me, clearly?
जी सर.
And okay, thank you so much. I'll share my screen. এরপরে যদি আপনাদের এই যে পরীক্ষার মধ্যে কোনো কনফিউশন থাকে যে ঠিক আছে সময়ের জন্য করতে পারছি না, একজনের না, বা এই ধরনের ইয়ে হয়, আপনারা আমাকে জানিয়ে দিবেন, ঠিক আছে? আমি চাই
Okay sir.
আপনারা প্র্যাকটিস করুন, বাট আমি এটাও করতে পারি না যে একটা জিনিস যেটাতে 20 মিনিট টাইম লাগে সেটা আমি 1.5 ঘন্টা দিয়ে দিব, সো স্টুডেন্ট 2 বার 3 বার করে ট্রাই করবে, দেন ইটস নট এক্সাম। সো আমার দুটারই হচ্ছে ব্যালেন্স করতে হয়। বাট আই ডু আন্ডারস্ট্যান্ড ইউর কনসার্ন, লাইক when we solve actually this math, as we are experienced, we know how to solve this. So probably it will take a few minutes for us to solve, but as they actually freshers, it may take much time in thinking like how to start, what would be the starting point. সো এই জন্য হয়তো বা একটু বেশি সময় লাগতে পারে আপনাদের। যদি এরকম সিচুয়েশন হয় আমাদেরকে একটু জানাবেন, ইনশাল্লাহ উই ক্যান কনসিডার, ঠিক আছে?
Okay sir, we'll keep that in mind.
ওকে, সো প্রথমে কি করবো, আপনাদের মিড টার্ম নিয়ে একটু কথা বলবো নাকি মিড টার্ম দেখলে আবার মন খারাপ হয়ে যাবে? কোনটা হবে ভালো? হুম,
Sir solution provide করে দিয়েন sir.
সলিউশন প্রোভাইড করে দিব।
জি স্যার.
ঠিক আছে, সলিউশন তো অবশ্যই ইনশাল্লাহ প্রোভাইড করে দিব। একটু দেখি কিভাবে সলভ করা যায় মিড টার্ম,
ওকে স্যার.
তবে কিভাবে করেছেন। টু বি অনেস্ট হচ্ছে আমার ফাইনাল অ্যান্সার নিয়ে হচ্ছে কোনো কনসার্ন নাই, লাইক আপনার ফাইনাল অ্যান্সারই হচ্ছে ক্যালকুলেটর টিপতে ভুল করলেন কিনা। হ্যাঁ, যদি ভুল করেন অবশ্যই কিছু মার্ক কাটা যাবে, বাট এর অর্থ এই নয় যে আপনি জিরো পাবেন। বাট আমি দেখবো হচ্ছে আপনার প্রসিডিউর ঠিক আছে কিনা, যে আপনি ঠিকভাবে আগাইছেন কিনা। একটু যদি ঠিক থাকে দেন ইনশাল্লাহ ইউ উইল ক্যারি ইন গুড মার্ক। সো যেটা বলছিলাম, আমাদের এটা হচ্ছে আপনার মিড টার্মের কোশ্চেন ছিল, 3টা কোশ্চেন ছিল। প্রথমটা ছিল হচ্ছে একটা মেশ অ্যানালাইসিস আর লুপ অ্যানালাইসিস, যেটা হচ্ছে আপনারা অনেকবার করেছেন। সো কার কোনো আইডিয়া আছে এটা কিভাবে করতে হয়, কিভাবে করেছেন এটা?
স্যার পার মেশে অ্যাকচুয়ালি একটা কারেন্ট অ্যাসাইন করে দেন স্যার. মানে
সো ইজি থিং হচ্ছে আপনারা এই তিনটাকে একটা ইম্পিডেন্স দ্বারা কনভার্ট করবেন।
স্যার আগে তো স্যার এটাকে একটাতে পরিণত করতে হবে ইম্পিডেন্সে.
হ্যাঁ, এটা কত হবে বলেন? 2 8 সে
-5
-5 সে।
5J.
হ্যাঁ, সো আপনি এটাকে হচ্ছে এই আকারে লিখবেন, মানে এটা হচ্ছে একটা ফেজার ফরম্যাটে নিয়ে যাবেন। যদি এটা ফেজার ফরম্যাটে নিয়ে যান, এই দুটো মিলে কয়টা? ধরেন এটা Z2, তো 1 + 3Z, এই পর্যন্ত ঠিক আছে? আর এটা তো
স্যার এটা
অলরেডি
ক্যাপাসিটর. স্যার এটা তো
একটা
ক্যাপাসিটর.
ক্যাপাসিটর।
জি স্যার
তাই?
1 ওহম.
ও আচ্ছা আচ্ছা আচ্ছা, তাহলে এটা ভুল লিখেছি আমি, এটা ক্যাপাসিটর, দেখতে ভুল করি এখন। সো -1J + 3J, সো এটা আসবে 2Z, সো বেসিক্যালি 290 ডিগ্রি অ্যাঙ্গেল। সো সিমিলারলি এটা কত? 10 ডিগ্রি, রাইট? এটা কত? আর 0 ডিগ্রি, যেটা আমি বের করবো সেটা আপনার স্টুডেন্ট আইডি থেকে পাবেন, এটা 10 ডিগ্রি। সো এই যদি সিচুয়েশন হয় তাহলে আপনি কিভাবে করবেন, দ্যাট ইজ এ গুড কোশ্চেন। তো দেখেন এই জায়গায় কয়টা লুপ আছে। এটা একটা লুপ কারেন্ট, ধরেন I1, এটা একটা লুপ কারেন্ট I2, এটা একটা লুপ কারেন্ট I3। ডান, এভরিথিং ইজ ডান। সো আপনি লুপ ইকুয়েশন লিখতে পারবেন? ফার্স্ট লুপ ইকুয়েশনটা কি হবে বলেন তো? একটু আমার সাথে প্র্যাকটিস করেন দেখি আমি মনে আছে কিনা। What would be the first loop equation? Oh, this is the current source, right? So এই জায়গায় কি I1 equal to how much? আগে বলেন I1 equal to how much?
2 at an angle 30 degree.
দেখেন এই কারেন্টটাই হচ্ছে এই দিক দিয়ে এন্টার করছে, so and living in that side, so it matches with the direction of the current source given here. So I1 is nothing but the 2 angle is 30 degree. So we don't need to solve that one at all. So what we have to do, we need to just write the KVL equation or the mesh equation at loop 2 and loop 3. So we were really careful about your solution. We didn't provide three unknown variables, rather only two unknown variables were there, should be there, if you actually do understand how to solve it. So at loop 2, what would be the loop equation? Loop equation is 1 I2 plus R. So with R, you know the value of R from your actually student ID plus 5. So the current would be I2 minus I3, and then is passing through the 10 ohm, so plus 10. The formula is I2 minus I1. I1 is already given. I1 is already given, and then minus 10 0 degree, because it's entering through the negative terminal. So this is one of the equation. This is one of the equation. You need to equate. You need to actually take all coefficient of I2 sorry, in one side and I3 in another side. Means something like this. I2 plus then I3, you'll put like this, equal to 10 angle 0 degree. Do you understand this part? Is it clear? If this is clear, you need to write the KCL at loop 3. So the loop 3 should be this impedance times current. So I3 times, let's say this is Z3, I3 is Z3, I3 is Z3 entering through the negative terminal, so minus 20 45 degree angle. Then with like two currents is passing through R, so R times I3 minus I2 equal to 0. So if this one is the case, I can take all the coefficient of I2, then I3 equal to 20 45 degree angle. So since we know I1, if I actually plug in the value of I1 here, then here we'll get only two equations, like two unknown variable I2 and I3. Here also two I2 and I3. How long will it take to solve these two equations in a calculator? So all you have to do is to know what is the value of I2 and I3. So I2 equal to del x by del, I3 equal to del y by del. That is the formula. All you have to do is to just calculate this. So do you understand this one? Now, is it actually clear? Is it clear now? Huh? So I believe it should not take much time. Now, how do you calculate what is the current passing through R? The current passing through R is nothing, is I2 minus I3. I2 minus I3. Since I didn't actually mention the direction, if somebody has written I3 minus I2, I will definitely consider it, because this is my actually shortcomings. If I actually consider, oh, this is the direction for current passing through, then you must write I2 minus I3, because I2 is entering, I3 is actually entering in from the other terminal, negative terminal. So plus and minus. So this is the current passing through actually the resistor. So you need to calculate what is the power absorbed by this. In many ways you can solve. One of the way is the current passing through that resistor. So I2 minus I3, then square times R. This is one of the formula, or calculate what is the voltage across this, then use the formula V square by R or V times I. So it's up to you. Is it clear now? I believe it should not take much time.
Is it only the magnitude, or the whole sinusoid equation of
Okay,
I2
that
and
is a
I3?
good question. If you check this equation 1 and equation 2, these both equations are a complex number in nature, right? So you will get I2 and I3 both currents as a complex. So since it's a complex number, then what you will get this is a complex number. It's a complex number, but you have to calculate actually the real power. So here we'll use the magnitude. So that's why this is a square. So a square means it's a magnitude. The phase doesn't count. Why phase doesn't count? we do. I can explain. But the power you don't need to actually use the phase, but this current, this current, like what is the current passing through this, or what is the mesh current I1, I2, I3. That is one of the actually questions, right? You need to calculate I1, I2, and I3. So for the power absorption case, you need to use the actually magnitude value because it's a real power. Now,
স্যার আরএমএস ইউজ করলে হবে না স্যার?
so you are trying to say, should we use the RMS value here?
জি স্যার।
RMS, probably we should not.
বয়েল স্টেডের স্যার বইয়ে একটা ম্যাথ ছিল, এখানে স্যার তারা আরএমএস ইউজ করছে, এই কারণে স্যার আমিও এক্সামে আরএমএস ইউজ করছি।
ঠিক আছে, I will check, but RMS ভ্যালু এখানে ইউজ করতে হবে না। এর কারণ হইলো যখন হচ্ছে ভোল্টেজ এবং কারেন্ট দুটো থাকে, আপনি যদি RMS ইউজ করতে চান কখন আপনারটা ঠিক থাকবে আমি আপনাকে বলি। যদি আপনি এই ফর্মুলা ইউজ করতে চান, P = VI, যদি এই ফর্মুলা ইউজ করতে চান তাহলে এইদার দুইটাই RMS অথবা দুইটাই হচ্ছে আপনাকে পিক ভ্যালু ইউজ করতে হবে। সো অ্যাকচুয়ালি যখন আপনি ইউজ করেন তখন the ফর্মুলা থাকে VI দেন হচ্ছে cos theta, এটা হচ্ছে ফর্মুলা থাকে, অথবা এই ফর্মুলা থাকে VI / 2 cos theta। সো দুটো ফর্মুলার মধ্যে ডিফারেন্স হচ্ছে এই ফর্মুলাটা হচ্ছে RMS ভ্যালুর জন্য আর এই ফর্মুলাটা হচ্ছে পিক ভ্যালুর জন্য। সো তখন হচ্ছে এই জিনিসটা ইউজ করা হতে পারে, বাট আপনি যখন হচ্ছে I² ইউজ করবেন অথবা V² ইউজ করবেন সেই ক্ষেত্রে হচ্ছে এক্সট্রা করে আর RMS ভ্যালু বের করার দরকার নেই। যদিও আপনি করে থাকেন, I'll consider like is it a notation or not, যে RMS ভ্যালুর উপর হচ্ছে বেসিস করে করা যায়। সো I will check ইনশাআল্লাহ। ও, আর কেউ যদি ইভেন এই এক লাইনও লিখেন they will get a mark, কেননা first loop current should be nothing but that 30-degree angle. So that is one of the questions you had for your exam. Was not that difficult. Now, sorry. Now here you need to calculate the current passing through that resistor R, but the direction is given. But you must use source transformation. How many of you actually had solved that one? Because this question is really easy.
I have done it.
You have done it? How about other students? Did you find it actually a bit difficult? Not
For
sure?
me, yes sir.
It's a bit difficult, right? Let's check it out. Is it really difficult or not? So my target is to actually calculate the passing through this. So I will try not to touch this one. I will try not to change this resistor value or this combination here. But other than that, we'll always actually change. Like, let's see, how does it go? You see that 10 ohm resistor is parallel with a short circuit because this is short circuit, right? So what will happen with this? This become a short circuit, nothing else. Do you understand this part? Probably not.
Yes, sir.
Yes sir, I made a mistake here. Yes sir.
You made a
Yes, sir.
mistake? Okay. Because it's a short circuit parallel with actually the resistor.
Yes sir.
Sorry,
Yes sir. It becomes
the capacitor.
really easy sir.
So
Yes, sir.
there will be nothing here. So now you check this one. Sorry, this is a capacitor. It's a single impedance, right? Let's say this is Z1. Can you calculate Z1?
Yes, sir.
3 plus 3 is
3 plus
6,
3.
sir.
Yeah.
Then you'll actually convert it to phasor, okay?
One is a resistor. Yes sir.
So look, this is 2 angle 0 degree. So these two branches are, let's say this is Z1. So Z1 and Z2 are in parallel, right?
Yes, sir.
So if Z1 and Z2 are in parallel, if I redraw the circuit, how does it look like? Since this is a short circuit, nothing is here, then I will put a impedance. This is, let's say, Z. P is Z1 parallel Z2, nothing else. Then এখানে হচ্ছে R টা, then the voltage source. Now there is one option. If I have two actually current source and pointing in the opposite direction, what you could do, okay, later on I will come here. There is one way of solving in really fast or really quick. So this is one of the things. So can you tell me, this is a voltage source with a series actually impedance. So we can actually convert it to a current source. Sorry. I can convert it to convert it with same actually impedance and a current source, right? What would be the direction of current source? Like this, right?
So upward.
Yeah, upward direction. So now everything is done. This is 390 degree. This is 6 something degree. What would be this value? The 10 divided by 8. This is 10 divided by 8, then 0 degree, because this is voltage, this is impedance. So the current would be voltage divided by impedance for the source transformation. So 10 by 8 angle is the same. Is it true? Is it wrong? It's wrong, because the impedance for this one is 8, angle is minus 90 degree. So so this is wrong. So what you have to do, 10 0 degree divided by 8 minus 90 degree. So it would be 10 by 8
90 degrees, sir.
90 degrees. So this should be the case. So now you'll use calculator for this. Now you see these three actually current sources are pointing in, some of them are pointing upward direction and some of them are actually pointing downward direction. So you can convert these three current source these three current sources as a single current source. So you can choose any actually direction for the current sources, for the equivalent current sources. Let's say I have considered in upward direction. So if I consider in the upward direction, then whichever of these actually current sources are pointing in upward direction, we'll consider it as positive, otherwise in the negative. So the 390 degree, this should be 390 degree because this is pointing upward direction. Then 645 degree, that would be a negative sign, 45 degree, and the final one 10 by 8 90 degrees pointing upward direction. So 10 by 8 then 90 degree. So that would be one of the case. If this is one of the case, we will redraw the circuit in such way. You see this one, the first one, a current source with a parallel combination of impedance. So we will convert it to a voltage source, the positive sign here because upward direction, and then there will be a series impedance, and then a resistor. This resistor we don't want to change, and then the voltage source here, and then all three current sources would be converted into a single current source parallel with an impedance. That impedance is nothing
So
but
could
this.
could we add the leftmost current source with the rightmost three?
Just a
So
second, let me
there,
finish. Then there are many ways of solving it. I'm not saying this is the only way of solving. I will actually teach you other way as well. So you see, this, since this is a series circuit, I'll just convert this thing. So finally, it would be like this: a voltage source, then an impedance, then a resistor, then again a voltage source, and then this actually current source and that impedance that can be converted into a impedance, and there is actually voltage source. This is plus minus. So you see, this is a series circuit. You know, if I apply a KVL here, let's say this is V1, Z, ZP, let's say ZQ, this is, let's say V2, this is, let's say, V3. What would be the formula for, KCL? The current passing through this, what would be this current?
Sir, I had a question. Can you please repeat the 390 minus 645 plus 10 by 8 90
Yes, yes,
degrees
yes.
part
I
actually?
will repeat one second. Even without actually doing so, you can solve the problem. So how would we actually solve this one? Current is actually entering from the negative terminal, so negative V1 plus ZP times I, then plus R times I, plus, then this is probably, this terminal is negative, this terminal is positive, so negative V2, then ZQ times I, and then the positive terminal is upward plus V3 equal to 0. So from this equation, you can easily calculate I. This is the answer. So now somebody asked me, how did I actually convert these three current sources in parallel into a single one? So this is nothing. These three, just like a resistor, if three resistors are connected in parallel, then we could write down, oh, this is equivalent to one resistor. Then we'll calculate what is the value of that resistor. So similarly, if voltage sources are connected in series, then we can convert this actual voltage sources into single voltage source, or if we have actually multiple current sources connected in parallel, then we can convert this current sources into a single current source. So for our case, three current sources are in parallel. So the equivalent current source may actually point downward direction or upward direction. It's up to you. Both cases you will get the same answer. But let's say we have considered that current source is pointing upward direction. That means whichever of these current sources are pointing upward direction, we'll consider it as positive, and otherwise in the negative, means in the reverse direction it will be negative. So since we are considering this is an upward direction, so this one is positive and this one is positive, while this one is negative because it's pointing actually downward direction. So if I perform, we know the value of each and every current sources. So if you perform actually phasor calculation, then we'll get what will be the resultant value of that current source. Now if somebody actually consider, no, we want to consider the current source is pointing downward direction, then the first one would be negative, this one would be positive, this one would be negative. The both cases will get the same answer. Now what if we don't want to use this one? There is no harm. So then we need to actually repeat the things quite a few times. This is a current source, then this is a what is it called, yeah, we need to actually do this one, then probably we can solve. Otherwise we need to actually perform source transformation few more times, so that would be quite hectic. You people did not get this part right, how to actually handle this. Is it your uh, was that your problem?
It's clear, sir.
Okay,
Only addition.
okay, yes, it's just a vector sum.
So we can actually get the equivalent part just by adding and putting the correct directions.
Yes, perfect. Yeah, this is the thing. So all you have to do, perform the vector addition, not the the algebraic actually sum, because we have direction, right? Direction involved in here. So I didn't think I don't think that was tough, but I do
Yes, sir,
understand.
that
Sometimes
wasn't tough
actually
at all.
phasor,
This, yes, sir,
yeah,
yes, I can
phasor
solve it within
calculations are a
10
bit
minutes.
time consuming. So yeah, next time I will actually
Yes, sir. The
spend more time.
calculation part,
Yes,
sir.
yes, yes.
Actually, sir,
I do
the
understand now.
problem wasn't making the equations or anything, but the calculation is the problem, sir. That's the problem.
একটু একটা মিনিট ওয়েট করে যাচ্ছে। Yeah, sorry for the interruption. এটা একটা কোশ্চেন ছিল, এখানে একটা কোশ্চেন না। What was the question? Using nodal analysis, you need to actually calculate the node voltages, and you also need to actually determine the current passing through the resistor R. Give me a second. থ্যাংক ইউ। সো কেউ আমাকে আইডিয়া দিতে পারেন এটা কিভাবে সলভ করতে হবে? ক্লাসের মধ্যে
Yes, sir.
একজন
There
জিজ্ঞেস
are.
করছে যে এইটা
উপরে
কি
স্যার,
করব।
স্যার,
Should I? Okay.
Yeah,
sir, one nodal voltage is 10 at an angle 90 degrees.
okay. So এর জন্য যেটা করতে হবে, first we need to actually define nodes, like what are
Yes, sir. There are
this
only
actually
two nodes
nodes.
here, right?
So let's check it out. This one would be one impedance,
So there are
this
three
one would
nodes.
be one impedance,
No,
this
that's
one would be one impedance, and these two, since it's in a series circuit, so we can consider this as a actually one one actually impedance, right? So if these are actually impedance, so we know, let's say this is Z1, this is Z2, this is Z3, and this is Z4. So these are, we can easily actually get the value of Z1, Z2, and Z3 and Z4 in terms of actually phasor. And let's say in Z5, this is 15, 0 degree, nothing else. So if these are the cases, what are the nodes? One of the nodes is this. Let's say we mark this node as A. This is a node, so mark this node as B, and this node is marked this node as C. So how many nodes are there? 3 nodes. So basically, if we have 3 nodes, generally we'll get 3 equations, right? We must write 3 equations so that we will get actually the node voltage at A, B, and C nodes. So this is our target, but we provided the question in such you don't need to solve 3 equations because the node voltage for the first A node is already been given. So this is one of the things. Now there is another trick. In the last class I mentioned, if a voltage source is connected between any 2 nodes which is not connected to ground, then we must use a method called supernode. Even without applying supernode, you can get the answer. But did you apply supernode here? Because the
Yes,
B
sir.
and C
Yes,
are
sir, I
connected
did
by
it.
a voltage source.
B
So if you
minus.
don't use actually supernode, probably you will get different answer. But this can be solved without supernode. In the last class, I have shown, right, that we how did we actually get the supernode concept. If you don't understand, you must interact with me. The sole purpose of this classes are like you will learn something. It's not how much I do understand or how much like আমি জানি অথবা এই টাইপের জিনিসগুলো আমার কনসার্ন না, কনসার্ন হচ্ছে আপনারা কতটুকু শিখবেন, সেটা কাজে আসবে পরবর্তীতে, ঠিক আছে? So if these are the case, we can easily write down this voltage source is VA. Since this is connected to ground, so VA minus 0 equal to this. So VA minus 0 equal to 10, 90 degree. So we already know the value of VA, 10, then 90 degree. If this is the case, since we will apply, the sorry, apply actually supernode. So this is one of the equations. Second equation is this voltage source is connected between B and C node, and the positive side is the B node. So we can write down VB minus VC equal to 530 degree. Can we write down this? This is number 1 equation.
Yes, sir.
This is number 2 equations. Can we write down this? Okay. So which is missing now? Now the supernode. Now the supernode. Can anybody tell me which one is the supernode?
Sir, now the whole thing has become supernode, and sir, as
This is a
3 ohm,
supernode, right? So if this is
yes,
a
sir, as
supernode,
3 ohm in parallel, so
what
it
would be
is
the equation?
cancelled.
Can
So VB
So-
minus VC equal
Yeah.
to 5 at an angle 30 degree.
Okay. I have already written this. So VB minus VC equal to here.
Sir, that capacitor, sir, it is in parallel. So then, sir, that will be also considered as.
Sir, I have a question about the capacitor. How will it
Yes, sir.
actually the equation be since the capacitor is attached?
Thank you so
Yes, sir.
much.
Sir, now
Actually,
it will be cancelled. Okay.
yeah, it will
So
always
if
cancel out. It will always cancel out. But আপনাদের তো এইসব নিয়ে টেনশন করার কোনো দরকার নেই, দেখেন কিভাবে করতে হয়। So
sir
since
current
the B
directionটা
and C nodes like together, yes, together it will be actually behaving as a supernode. Let's write down the equation as supernode. So let's say we'll start from the point B. So point B, how many actually connection are there? This is one connection, this is another connection, this is another connection, and another is the voltage source, so we don't need to write at all. So now the V is connected to A with a like impedance in Z2, so we'll write down VB minus is at 5. Then will Z3. So we'll write down VB minus VC divided by actually Z3. Now, oh, some of you will be really surprised. Oh, so we don't need to write this part. Yes, the answer is yes. You don't need to write this part. And why? Let me explain actually. So I have finished all the connection at node B. So I need to actually go to node C now. So plus, what is the node C? This is connected to node C. This is connected to node C. This is also connected to node C. So let's try for the C is connected to A. So VC minus VA divided by Z1. Do you understand this part? C connected to A with an impedance actually Z1. So I have written that C is connected to B with an capacitor. The value is Z3. So we'll write down VC minus VB divided by Z3. Then plus the C, this is also C. So C divided by, C is connected to ground. So VC minus 0 divided by Z4. And this current is actually leaving current from C. So plus actually IS equal to 0. Do you understand this actually, KCL? If you do
Sir,
understand,
can't we only apply it on node C and take the consider the super node? Then we get two equations.
I didn't get your point. I will get back to that question once I'm done. So you check this one, and this one will cancel out. That means if we don't consider the like impedance connected in parallel to that voltage source, I mean the super node, still is fine. So how many actual equations are here? We know the value for A. So if I plug in, then we will get some equation like this: PB times something plus VC times something equal to something. So this is one equation, and another equation is this. So solve, only you have to solve these two equations. That's it. If you can solve this equation, you, you will get all the node voltages. And what is the current passing through that resistor? The current passing through that resistor is nothing but the VC divided by let's say this is ZP ZS divided by ZS. Is it clear? Now, what is your concern? Like, did I make any mistake? Oh, what is your concern?
Sir, can I consider the node C and the super node? I mean, how much current is leaving and passing,
Only at
entering
C.
at node only at C, and and considering the other equation with node super node
At B.
VB minus VC. Yes, sir.
No,
VB minus
because you need to
VC.
consider B as well. So you had two options. Either if you consider actually that B and C as the supernode, you need to write the KCL at B and C together. This is one of the one options. Otherwise, there is another option. What I can do, I can take a snapshot somewhere so I can solve it. Will I take this one? Sorry. Yes. There is another actually question. So copy. So now that was A. Was that B or C? What did I write? B, right? So this is B and C. What one of your actual friends was trying to say, we'll consider this one as the actual supernode, but we wanna write down the KCL equation only here. Then this is not correct. Now forget about the supernode. We know the value of VA equal to 1090 degree. So all we have to do is the KCL at B. So KCL at B node. So this is the B node. How many currents are there? One of this current is this, another is this, another is this, another is this. We don't know what is the current passing through actually this voltage source. Let's say I, V. So the formula would be VB. This is Z1, then Z2, Z3, Z4, and this together in Z5. So at B node, the formula is VB minus 0, 15. 15 means Z4 plus VB minus VA, VB minus VA, and VA is known, divided by Z1 plus B is connected to C, so VB minus VC divided by Z3, then plus that IB current is leaving, let's say this is the current direction, so plus IB, that equal to 0. So this is one equation. Another equation should be KCL, the KCL at node C. So now node C, how many actually currents are there? So this is one of the current, this is one of the current, this is one of the current, and this is one of the current, because this is also C, this is C, so on. So if this one is the case, we'll write down VC minus VA, because C is connected to A by this actually impedance Z2, and then C is connected to B by a capacitor, so ZC minus ZB divided by actually this impedance is Z3, and the current passing through actually this actually voltage source is nothing but the IV, but the direction is entering, so I will put negative IV. Then another current is passing through this, so we'll write down VC minus 0 divided by Z5, because this is the impedance Z5, and the current is leaving, so I will write down IS equal to 0. So this is another equation. So if you don't want to write actually the what I wanted to say,
স্যার আমি বলছিলাম যে সি নোডে যতটুকু কারেন্ট ঢুকবে আর বের হবে এটা দিয়ে তো একটা ইকুয়েশন হবে, সেটাতে তো ভিবি আসবে,
that is that
ভিএও
equation.
আসবে,
This is
আর
that
আর হচ্ছে
equation.
আরেকটা ইকুয়েশনের কথা বলছি, যেটা হচ্ছে ভিবি মাইনাস ভিসি ইকুয়াল 5 at an angle 30 degree.
হ্যাঁ, আমরা তো তাই করেছি এর আগে আপনি যদি এটা সলিউশন দেখেন, এই সবার আগে লিখেছি VB minus VC equal to 530 degree.
হ্যাঁ, মানে এই দুটাই
It's enough.
সি বের হয়ে যাচ্ছে।
আপনি টার্গেটে এই দুটো থেকে এইভাবে বের করেন, বাট দুটো ইকুয়েশন কম্বাইন করলেই কেবল সুপার নোডের ইকুয়েশন পাবেন। মানে আমি যে এই যে এখন যে দুটো ইকুয়েশন লিখেছি না এখানে, কই গেল ওটা, এই যে দুটো ইকুয়েশন লিখছি না বি এন্ড সি, আপনি যদি এই দুটো ইকুয়েশন যোগ করেন তাহলে এই আইভি কারেন্টটা ক্যান্সেল আউট হবে যদি 1 প্লাস 2 করেন। কেননা আমি তো জানি না হোয়াট ইজ আইভি কারেন্ট পাসিং থ্রু দ্যাট ভোল্টেজ সোর্স, কেননা আমার শুধু ভোল্টেজ সোর্স দেওয়া থাকলে সেটা আমি কারেন্টের ইকুয়েশন লিখতে পারি না, কেননা আমি তার ইম্পিডেন্স জানি না। ধরে নিছি একটা কারেন্ট পাস করে,
মানে স্যার এভাবে হবে,
হ্যাঁ
মানে ভিবি মাইনাস ভিসি দিয়ে হবে।
হ্যাঁ হবে, ঠিক আছে। এরপরে আরেকটা ইকুয়েশন লিখবেন, সেটা হচ্ছে ভিবি মাইনাস ভিসি দ্যাট ইকুয়াল টু 530 ডিগ্রি। সো আপনি যদি এই ইকুয়েশন দুটো সলভ করেন, দুটো আননোন থাকবে, এটা হচ্ছে আপনি সলভ করতে পারবেন। সো অ্যাকচুয়ালি আপনাদের হয়তো বা টাইম একটু কম ছিল, কেননা এটা এই ধরনের জিনিসগুলো বোঝাও হচ্ছে টাফ, এন্ড phasor calculation it takes really much time, especially when you are new to complex calculation. So next time inshallah I will actually try to provide more time, and after checking your midterm exam I will decide whether we'll be having another actually assignment or this sort of actually things or not. So এটাই হচ্ছে আপনাদের মিডটার্মের কোশ্চেন ছিল। ক্যালকুলেশন বড় নয়, এই জিনিসগুলো বোঝাটাই এটাই টাফ ছিল হয়তো বা, কিভাবে ফাইনাল দুটো ইকুয়েশন হচ্ছে আপনি লাইক ডিফাইন করবেন এবং আননোন কিভাবে দুটো হচ্ছে আননোন সলভ করবেন ক্যালকুলেটরে। So now get back to the assignment we had. So some of you had actually mentioned in the Google Classroom that there were a few questions. That question was said by another teacher. So there were actually some questions on Thevenin or superposition theorem, is it? Have you checked the assignment question,
Yes,
or
sir.
probably you have not? So we'll try to actually cover this thing in our actually live session. So today I will give you a hint of something you already had known. It's called Y delta actually transformation. Okay. I think yeah, the last day I had actually covered till here. So I wanna actually set this a bit fast. Okay. So I believe all of you had actually heard about Y delta conversion, especially in DC circuit. You had a configuration for resistor, and you can convert it to the delta configuration within a resistor, or vice versa. So we can apply this actually conversion in a rule in AC circuit as well. And to be honest, the Y delta like transformation, these were not so important in like DC circuit, but in AC circuit, these are really actually important, especially when you will be dealing with three-phase actually circuit. Well, probably in the last actually few weeks, we'll be dealing with actually three-phase actually circuit. That time it will be really helpful. So Y delta transformation or delta Y transformation are very important technique for analysis of circuit. So in AC circuit, all we have to do, as I said, all the circuit theorem, whatever we have learned in DC circuit will be applicable, but we must replace that voltage source and current source by a phasor number, means it's a complex number. It should have a magnitude as well as actually phase. No matter the phase is zero or not, we must actually represent in terms of complex number. And other thing, all the resistance will be actually converted by the equivalent actually impedance, like the combination of resistor, capacitor, inductor, or so on. And so how do we actually convert these things like Y to delta or delta to Y? So for the convenience, what we'll do, we'll consider that delta impedance are given by the alphabet A, B, C, and D, and so on. And the equivalent Y impedance will be actually given by the number 1, 2, 3. So if it's written 1, 2, 3, it means these values are given in terms of Y connection. And if these are written in terms of like alphabet A, B, C, then we'll understand this is given in terms of actually Y connection. So we all know about this sort of conversion. So first, let's talk about Y to delta connections. That means I have a delta connection. So this is a delta like things. So in Greek letter, this is called delta. This is called delta. This is called delta, in Greek letter actually. So now I can convert these delta terms into equivalent Y terms. How? By considering this sort of configuration. Now, so here is given, we can actually draw the equivalent Y connection from a delta connection. So now we need to find out what would be the value of Z1, then Z2, and Z3. This is so simple. So if I want to calculate Z1, so we need to check. Sorry. So what is the product of the impedance of adjacent side? Means Z1 is connected by two delta impedance. So we will take the product of this divided by the summation of all three actually impedances. Similarly for Z2 is connected, like there is a connection of these two impedance from actually the delta connection. So we'll take the product of these two divided by summation of all three impedance. So the formula is this is called product. This is called product of adjacent So adjacent, or we don't need to write in this way. It would be quite complicated later on. So this is a very simple formula. Like we will, if I want to calculate Z1, so I have to check Z1 is connected by these two actually impedances. So I will write down ZB then ZC divided by the summation of all three impedances in connected in actually delta connection. So summation of Z, that is given by ZA plus ZB plus ZC. Do you understand this thing? This is quite simple, right?
Yes, sir.
Probably you have learned it for resistance in a DC circuit actually combination. So similarly for the delta to Y, this is also simple. Now my connection is given in this way. So delta is given. So I want to convert the equivalent to Y. So this is the equivalent to Y connection. If this we want to calculate the Y connection now, sorry, Y is given, the wrong thing. Y is given, but we want to actually draw the delta actually connection. So this Y is given, but we want to calculate the delta connection. The formula is this is called a cyclic sum of taking two impedances at a time. Cyclic sum of impedance taking two at a time divided by the opposite impedance. What does it mean? So Z1, Z2, and Z3 are connected in Y. We need to calculate, we need to draw the equivalent to delta connection. So we'll take the cyclic sum of taking two, means Z1, Z2, then Z2, Z3, then Z3, Z1, and so on. So this is called the cyclic sum, Z1, Z2 plus Z2, Z3 plus Z3, Z1. This is called cyclic sum. 1, 2, 3. So 1, 2, 2, 3, and then 3, 1. So 1, 2 means Z1, Z2, 2, 3 means Z2, Z3, and 3, 1 means Z3, Z1. So this is the cyclic sum of impedances taking any two at a time. So that is one of the things, divided by, if I want to calculate ZA means what is the opposite side opposite side of this actually impedance, then we'll divide by Z1. Means if I divide this thing by Z1, then I will get the equivalent delta impedance for the opposite things, means the opposite of this is this. So if I divide by Z2, that means I'm taking this, so opposite of Z2 is ZB. If I divide by Z3, so the opposite thing is ZC. So in real exam, you will calculate this thing first, and you will write down this value, because this value doesn't change. This value doesn't change for Y to delta configuration. And for the delta to Y configuration, that sum doesn't change. So we'll calculate the sum first, and then we'll actually perform in whatever on the numerator here. So do you understand this?
Yes,
If you
sir.
understand, and this is quite actually simple, the Y connection is also called a T connection. Let's say this is like a connection. So the equivalent connection is this, means both connections are equal. We all know this, right? So now the equivalent delta connection should be like this if I convert. So like this or something like this. So similarly, delta connection could be written as a pi configuration, like this is called pi, although this is a ground, or in the other point. So this is not a ground, another actual point. So since these points and these points are same, and these points are same, so basically this is connected like this connection could be given like this. So do you understand this two actually part? So if these two parts are the same, now what if for a Y delta configuration, for Y to delta, my target is delta is given, and then we are gonna get the Y configuration. For the delta configuration, this and this and these three impedances are same. Let's say both impedances are Z. Then what would be equivalent Y configuration actually value? So if I consider ZA, ZB, and ZC are equal, then I will get Z square here divided by 3Z. So I will get Z by 3. Similarly, I will get Z by 3 here. Similarly, I will get Z by 3 here. Do you understand how did I get Z by 3? If I said the impedances for delta connections are equal, then and everything is Z, so ZB times ZC means Z times Z means Z squared, and ZA plus ZB plus ZC is nothing but the 3Z. Do you understand this part?
Yes, sir.
Do you understand this part? Now tell me, from delta to Y configuration, impedance increases or decreases in generally? Impedance increases or decreases? It decreases, right? Like here,
Yes, sir.
it is
It's
decreasing
parallel.
by a factor 3, but only when all the impedances are equal. Similarly, for Y to delta configuration means the Y configurations are given and all the actual impedances are equal, means Z1, Z2, and Z3. Let's say Z1 equal to Z2 equal to Z3, that equal to Z. If I replace this one, the equivalent actually delta configuration values should be like this. This is 3Z square divided by Z. So you will get 3Z. Means in both cases, in delta configuration impedances are actually greater than Y configuration. So that is what is written here, what we have already done. We've already done this. So we'll check with the only one question here, and today I will stop here after this actually question. So let's say we are targeted to calculate what is the total impedance ZT of this network. Like in this circuit, probably you were asked to calculate what is the equivalent resistance for a given circuit, or the combination of resistor, right? So here we can also do the same, but only thing is we'll be dealing with actually impedance. Now, first, this is an impedance, this is another impedance, these two are a single impedance, this is another impedance, this is another impedance. So these are 5 actual impedance. This is something like called a Wien bridge or something, but this is not our task. So you can see we have 2 delta configuration. One is this, or another one is in the bottom. So it's totally up to you which delta block you wanna actually change. Means you can change this delta block, or you can change this delta block. It's totally up to you, and in both cases you will get the same answer. And my target is to calculate what is the impedance between this and these 2 points. So I will not change only these 2 points. Yes. For this circuit, what they have done, they had actually convert the upper delta connection. So we will also do it for the lower delta connection, and you will get the same answer. So how do you actually solve? It's a delta connection, so I will draw a Y connection. So what is the formula for that Y? Means Z1 prime. So Z1 prime means Y configuration means, what does it mean? Z1 prime means whatever values are connected in the adjacent side, this one is connecting and this one is connecting. So I will put these two value divided by the summation of this one, and this one. So this is pretty straightforward. Similarly, for Z2 is connected between this one and this one. So I will write this times this divided by summation of all. And then similarly for this value is connected between this one and this one. So I'll write down this one times actually this impedance divided by summation of all. So once we get to know, the equation would be looking like this. So once this is done, this impedance and this impedance are in series, and this impedance and this impedance are in series, because these B and C nodes are not connecting to any other actually port, so it's nothing but a node. So these two will be converted into a single impedance, these two will convert it into single impedance, then these two will be in parallel. Let's have a look. So it's something like this, means this one and this one are in series. So basically what we are doing is converting these two into one, these two into one, these two are in parallel, so that would be one. This one and this one are in series, so once they are series, we can perform the formula for series, and we will get back to the actually final results. So how about in another way? Can we actually solve it in another way? Let's try it. So this is the configuration. This is the question. My target is to calculate the total impedance between actually these 2 points. So how do you do so in another way?
Sir, we can just change the bottom delta into y.
No problem. Can we actually go for this?
Yes, sir.
Okay. If I want to calculate this value, then I need to multiply this one with this one divided by summation of this. Then if I want to calculate this value, then I will multiply this times this divided by summation of this. Similarly for this, I will multiply this and this divided by everything. So the equivalent thing should be the upper box we didn't touch. So this is one of the thing, and then actually this two, right? So can you tell me these two are in series, these two are in series, right?
Yes, sir.
Then this is connected like this, means this node is this and this node is this, and this is connected with this. Similarly, these two are in parallel, so we'll get a single impedance, then another impedance here, and then it will get back to only one impedance, and between this point, let's say A and B, A and B, A and B point, A and B points, then A and B points, and so on. Do you understand this actually Y delta conversion?
Yes,
Any
sir.
any confusion? All you have to do, how to actually perform that that calculation. So this is what you need to check. This one is the case. There's another actually delta to Y connection. You can have a look, and you may actually give a try at home. If you have any problem, I will actually help you to solve it. So there is another thing is called delta to Y to delta connection, that is also easy. You may actually like practice that one. So this would be it for today. Any question? Any question?
No, sir. No, sir.
Okay. I have actually extended the deadline for assignment 1, right? Because I have not covered that Norton and Thevenin theorem
Yes,
so
sir.
far. So once I will cover, then you can actually practice solve this for assignment.
Okay, sir.
Okay. If there is no actually other question, we'll actually end our session here. Thank you so much for joining once again. Have a good
Okay,
day.
sir. Thank you, sir.
Yeah, no problem.
Pray for us,
Sir,
sir.
Assalamu alaikum.
Walaikum assalam.